So our next question is from Atlanta, from Elizabeth. Dr. Math, is a permutation when I get a perm? Alright, Matthew, so let's jump in here and let's figure out what the heck are permutations and how do I use them? Alright, so first of all, we got this formula that I want to introduce you to of permutations, and I want to look at our exclamation marks, right? Well, they're not exclamation marks. They are if you're in the English class, right? But these are our factorial symbols, right? And so when you see a factorial, let's begin there. So for example, let's say I gave you 3 factorial. What that tells us is this is really 3 times 2 times 1. So you start at that number that they give you and you keep multiplying, keep dropping the number and multiplying all those. And you always stop at 1. You don't want to go down to 0 because if you have 0, anything times 0 is going to wipe everything out and give you 0, right? So we always stop at 1. So just a quick little note, 3 factorial is 3 times 2 times 1. If I had 5 factorial, 5 times 4 times 3 times 2 times 1. All right, so make sure you got that in your notes. All right, so what we're gonna need is you're gonna need a total number of objects, and I'm just gonna make up a number. We'll look at some examples right now, but let's say you have 5 total objects, so n is 5. And we're gonna look at the permutation, and out of those 5, let's select a subgroup. And let's say we're gonna select 3 out of those 5. All right, so just to show you how the math is gonna look, we go ahead and everywhere we see n, we're gonna plug in 5. So we have 5 factorial divided by, in parentheses, you have 5 minus 3 factorial. 5 minus 3 factorial. And what's nice is most of your calculators have this permutation button, but if it doesn't, I want you to understand how to do the math by hand, right? And so we have 5 factorial divided by 5 minus 3, right? Order of operations. So we have 2 factorial. And what I like doing, especially as these numbers get larger, is that 5 factorial, I write it as 5 times 4 times 3, and I just put times 2 factorial. I know I could put times 2 times 1, but again, as I'm dealing with larger numbers, right, this idea here is going to save us a lot of time down the road. And then I'm going to divide that by 2 factorial. So the reason I stopped at 2 factorial is so that these would cancel out. So you could see if these numbers were larger, say like 13 factorial, and this was like a 7, I would want to, as I'm going down 13, 12, 11, 10, 9, 8, 7, I would stop at 7 factorial so that those would cancel. So that's the big idea there. That's the big picture, all right? So those 2 factorials would cancel out. So in this answer, I'll be left with 5 times 4, which is 20, times 3, which gives us 60. All right, so that's how we're gonna do the calculations once we're dealing with the numbers. All right, so let's dive in here and let's really understand, when do I use these permutations? Well, follow me. All right, so as we dive in here and learn about these permutations, the biggest thing you need to do is smash that like button and subscribe if you haven't done so. All right, so so look at this. If you have a set of objects, right? So let's say I have a set of donuts. And so if you have a set of objects, a permutation is the arrangement of all or part of a set, all right? With regard to order. So what that tells us is the order is really important, and that's what really defines the permutation, is we have a certain order. That order matters. Say you have a bunch of people and you're gonna select some to be president, vice president, and secretary, right? Those positions are important and they each do different things. So whoever's, if I switch the president and the secretary, that's gonna make a big difference, right? Because that order matters of who holds what position. Or if I have a first place, second place, third place winner, and they all get gold medal, gold, silver, and bronze, right? Dr. Math wants the gold, right? I don't want the bronze. So the order matters. Okay, so that's what we're looking at when we're talking about permutations. We're really saying that the order is important. So let's look at an example. So Dr. Math is judging a pie competition for Pie Day. And who doesn't love them some good pie? So he has 7 pies that he will be judging and has to award a first, second, and third place winner, as each will be given $100, $50, and $25 respectively. All right, so again, if you're a first place winner, you're getting that $100. If you're a third place winner, you're getting that $25. So that order matters, right? You want to be that first place winner so you get the greatest prize, right? So how many ways can he, and the rest of the question, I wrote it down in white. So how many ways can he choose 3 winners, right, out of these 7 pies, right, these 7 contestants? So how many ways we could do that? So here, because the order matters, we're looking at permutations, all right? So how many ways can he choose 7, right? We have 7 pies that we're gonna be judging, and out of those 7, we're gonna be looking at those top 3, right? So here the order matters. So that's why we're looking at permutations. If I just said pick the top 3 and I didn't care about first, second, and third, then we're looking at something called combinations that we'll look at in our next video. All right, so make sure you subscribe so you don't miss that. All right, and you won't miss delicious pies. So here, remember our N, let me write this down, our N is 7 and our R in our formula is 3. And so let me just up here write down the formula again. We had N factorial divided by N minus R factorial. So keep writing down the formula until you have it down, or make sure you know how to use technology if your teacher or instructor allows you to use it. All right, so we have 7 factorial divided by 7 minus 3 factorial. Make sure you do the parentheses first. So I'm going to do 7 times 6 times 5 times 4 factorial. And the reason I'm stopping at 4 factorial is because when I do the subtraction in the denominator, I end up with 7 minus 3, which is 4 factorial. So it's easy for me to see that those factorials are going to cancel. So I'm left with 7 times 6 times 5. So 5 times 6 gives me 30. 30 times 7 gives me 210. So there's 210 ways, right, that out of these 7 pies, I could choose a first, second, and third place winner. All right, so this is the idea behind permutations, and I don't know about you, but I need a pie break.
All right, Pie, I'm just gonna do this. And if you get eaten, it's your own fault.
All right, so let's continue the march. Suppose you were asked to list in order or preference, right, the 3 best movies you have seen this year. All right, let me think. What are some good movies I've seen this year? If you saw 10 movies during the year, right, and I think during this year, since we're in lockdown, I think people see more than 10 movies. Am I right? And how many ways can the 3 best be chosen and ranked? So we're not only choosing the top 3 or the best 3, we're also gonna rank them. So when you're reading these problems, make sure you're asking yourself, does the order matter? Because we're ranking them, you know that the order matters, right? So if you guys haven't, make sure to check out the Dr. Math documentary on Netflix. That's the #1. But anyways, back to this. So we can see here that we have 10 objects, 10 movies in this case, and out of those 10 movies, right, we're gonna choose the best 3, right? We're gonna choose the best 3 because we're ranking them. So that's why we're looking at permutation. So once again, our N is 10 and our R is 3. We want to identify the total number, which is N, and then how many we're choosing from that total. And so plug it into our formula. We have N factorial, so 10 factorial divided by 10 minus 3 factorial. And so we end up with 10 times 9 times 8 times 7 factorial. And again, I'm stopping at 7 because in the denominator, 10 minus 3, I end up with 7 factorial. And so I'm going to see that these 7 factorials are going to cancel. So it's going to leave me with 10 times 9 times 8. So 9 times 8 is 72 times 10, we get 720, right? 720 possibilities. There's 720 ways that you could make these rankings. All right, so hopefully that's making sense. Any questions? All right, and before you leave us, we want you to look at this problem right here. So you got 10 board members, and we're saying in how many ways can this board elect a president, vice president, secretary, and treasurer. So we want you to comment down below, is this a permutation, right? Does the order matter? And go ahead and put down your answer. Tell us what you got below. All right, mathletes, hopefully this was helpful. Make sure you like, subscribe, and we'll see you mathletes in the next video. Peace. All right, mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.